I found this graphic online and I wanted to share it with you all. So this comes from the Glenn Research Center, which is a subsidiary of NASA, and I think it does a great job of simply listing out the different quantities that we're going to be looking at throughout the year. They're not all here. We're missing some quantities with electricity, magnetism, and waves, but it does a good job of looking at the first half of our course. In each quantity that we introduce in this class, I'm going to ask if it's a scalar or a vector quantity. You're going to have to know or to be able to identify which it is. So let's do definitions first. A scalar quantity only has magnitude. And a lot of students get tripped up on this word called magnitude. It just simply is the amount. Okay, so for example, if I take a length, which is one of my scalar quantities, let's say I measure a distance of 5 meters, the magnitude is 5 meters. A vector quantity, on the other hand, is not fully defined if you just give a magnitude. So for example, if I take that 5 meters, well, that's a length. But if I say 5 meters east, that now has a direction. That gives me a vector quantity, and under our vector quantities list, you'll see that's a displacement. So a vector quantity has to have both magnitude and direction. So if we look at our scalar quantities, length, area, volume, these are all going to be distances. So length is distance, area is distance squared, volume is distance cubed. We've got speed, mass, density. Notice mass and density is probably the easier scalars to understand. It doesn't matter the direction your body is pointed in. Your mass is not going to change. The density of a penny, regardless of where it is in the universe, heads up, tails up, it's going to have the same density. We will work mostly in the academic and honors level courses with length, but we're just going to simply call that distance. We're going to look definitely with speed, mass, energy, work, and power. Those are going to be our big scalar quantities. If you're joining me for the IB Physics program, we're also going to look at area, volume, density, pressure, temperature, and entropy. Now our vector quantities have to include direction. Displacement is the vector quantity. You would typically say distance, but that's our scalar quantity. Velocity, which is different from speed because it includes direction. Acceleration, how fast you're changing speed. Or if you're changing direction. Momentum, that's going to be a quantity of motion that we talk about. Force. Force is pretty easy to think about in terms of vector quantities. Which force is pulling you down right now? Well, of course, gravity. But if I had said which force is acting on you right now, you wouldn't be able to identify it unless I specified the direction. You also have an upward force acting on you now, which is the normal force, but the direction gives it definition. And we'll also look at weight, which is different from mass. We've got mass as a scalar, weight as a vector. You also see listed here as lift, drag, and thrust. Those are specific forces that we look at when we are analyzing airplane motion and rocketry. Those don't come up in this course too often, but if you take a basic engineering physics course at the college level, you might see those listed there. Those are all vector quantities as well. There are a lot more quantities that we will look at this semester, so just be aware that the definitions will get you very far in identifying. A scalar only has magnitude, while a vector quantity has both magnitude and direction.